This is Note Taking Guide 3.5 for Math 1. Today we're going to talk about some more special parts of the graph, or identifying special features of the graph. We're going to talk about today interval of increase and decrease, and interval in positive and negative. So for just a minute I want to zoom in here and focus just on this picture right here, and I want you to look at a few things, okay? So here's our graph right here that we're looking at. So what we're really looking at when we're talking about interval of increase and interval of decrease is we're talking about when we have positive and negative slope. So they wrote increase along right here, but I want you to think about it as a positive slope. The slope is positive until you get to here. Then the slope is constant, which means it's 0 right here. And then the slope is positive again right here. And then the slope is decreasing or negative right here. So if we're going to talk about the interval of increase or the interval of decrease, what we're really looking for is how far left and how far right is our graph increasing, or how far left to how far right is our graph decreasing. So we're going to be writing those intervals that tell us when our graph is increasing or decreasing. So let's look at and see what it says. So back here it says find the interval of increase. So interval of increase is when we have positive slope. We actually have already marked that with our purple lines here. We have positive slope starting here and ending there. We also have positive slope again starting here and ending here. So we have positive slope those times. So what we're going to do is we're going to write intervals that talk about how far to the left and how far to the right do we have positive slope. Well, how far left does our positive slope go? I probably need to erase some of this stuff so we can see. This positive slope goes over to -5. How far right does my positive slope go? Well, my positive slope ends at -2. Then I just need to decide whether or not it's parentheses or brackets at those points. So let's check the end point over here. It's solid. So I know I'm going to have a bracket around it. And let's check the end point over here. So let's just talk about this for just a minute, because when we come to this point right here and we're trying to decide if it's a bracket or a parenthesis, the question is, at that exact point, is that slope increasing or is that slope going to be constant from over here? So because we don't know if it's increasing or constant right there, we're going to put a parenthesis around it because we're not 100% sure. Okay, the interval of decreasing, how far left to how far right are we going, is next. I forgot though, on this interval of increasing, we actually have one more interval we need to look at. So let me clean up this graph a little bit here and let's write our interval of increase again. So the interval of increase is where we have positive slope again. We have positive slope between those two spots to get that slope right there. So our second interval is going to be from 1 on the x-axis to 3 on the x-axis, because it's how far left to how far right do we have positive slope. Again, we don't know at those endpoints whether or not it's going to be increasing or constant, and we don't know here if it's going to be increasing or decreasing. So we're going to leave it as parentheses. Okay, the next one is our interval of decrease. Decrease is where we have negative slope, so from here to here, we want to know how far left and how far right we have negative slope, so I'm just going to find those points there. So I have negative slope starting at 3, I have negative slope ending at 5, so I'm going from 3 to 5, and again, because this one we don't know exactly where it's going to be, if it's increasing or decreasing at that point, we're going to put a parenthesis, but here we do know that it's decreasing, so we're going to put a bracket there. All right, the last one on here that we haven't talked about is the interval of constant. Constant is when you have no change, so in between here and there. Again, we're just finding how far left and how far right. Our slope is constant, so we're just going to write that interval. I went -2 to the left. I went 1 to the right. And then again, these are both sandwiched in between, so I'm going to do parenthesis and parenthesis because I don't know exactly at those points if the slope is constant or increasing, or constant or increasing on this side. So we'll leave it as parentheses. So that's interval of increase and decrease. We're talking about slope when we're talking about interval of increase and interval of decrease. The next thing we're going to talk about is whether or not we have positive or negative intervals. So positive and negative intervals come from looking at the x-axis. Everything above the x-axis is considered positive, and everything below the x-axis is considered negative. So when we take a look at this line that we have drawn here, here's my line right here, I want to look and I want to see where it crosses the x-axis at, and it actually crosses the x-axis of 1. So everything from here over this direction is going to be positive because it's above the x-axis, and everything on this side is going to be negative because it's below the x-axis. So we're going to write our intervals for that. Remembering that we always start from the left to the right. So how far left is this going to be negative? Well, it goes forever to the left, so negative infinity because of the arrow on the end. And then how far right does it go? Well, it goes to 1. Right at that point, I'm not determining if it's positive or negative because it could probably be one or the other. So I'm going to put a parenthesis there. And then my interval over here of positive, oh, I'm sorry, I just did the interval of negative in the positive spot. I have to move that down here because negative is below the x-axis. I think I said it right. I think I just wrote it in the wrong spot. So the interval of negative is below the x-axis. The interval of positive is above the x-axis. So we're going to start it at 1. And we're going to end it going forever to the right, so positive infinity. All right, so let's look and see if we can do a couple of these problems. Oh, we have one more thing to figure out still, sorry. We haven't talked about end behavior. So let's go over what end behavior is, and then we'll go from there. So end behavior is something really simple. It's actually looking at the ends of the graph and seeing which direction they're going. So for instance, let's look at this for just a minute. As my x's go towards negative infinity, meaning my x values are going towards negative infinity, what are my y values doing? Well, my y values on my graph are going down. So I would be like, oh, as my x values go towards infinity, then my f of x values are also going towards negative infinity. So this is what we're doing, is we're looking at what the ends of our graph are doing. So again here, this time, as I look at my x values are going towards positive infinity. What are my y values doing? Well, my y values are going down, so my f of x values are also going towards negative infinity. So when we're looking at that, and that's what it says over here in the same table over here, is it just tells us what we're looking at here. So let's look at this one right here, this graph. So if I look this way, which is when my x values are going towards negative infinity, I need to know what my y values or my f of x values are doing. Where are they going? Well, they're going down, so they're going towards negative infinity. Then if I come and I look at this other side, what's happening over here, then as my x values are going towards positive infinity, because my x's are getting bigger and bigger this way, what are my f of x values doing? Well, my f of x values are going up, so they're going towards positive infinity. So that's what end behavior is. It's looking at the ends of the graph and deciding which direction they're going. Okay, so let's see if we can do all of these things on some of these graphs. So the very first thing we're going to do is do increase and decrease. If you remember, increase and decrease have to do with slope. So I'm going to mark the slope on the graph. So this is a negative slope, negative, negative, negative. It changes to positive here. It's constant there, and then it's positive here. Okay, so I'm going to have to write my intervals of increase. My intervals of increase are where my slope is positive. So where does my slope start positive at? It starts here at -1. And where does my slope end positive at? It ends right here at +1. Now I have another set of positive here, so I'm going to put this little union sign here, which means I have another set of positive. And I'm going to start my positive again right here, which is over at 3. And then it stops when it comes over here, 4, 5, 6, I think that is. It's hard to read that, so just make your best guess. Okay, our interval of decrease is when our slope is negative. So when is my slope negative? Well, my slope is negative over here. So my interval of decrease would be how far left to how far right I'm negative. So how far left is this going to go? Well, it's going to go towards negative infinity. And how far right does my decrease go? It goes to -1. Okay, the next thing we're going to look at on our graph is our positive and negative. Positive and negative is everything above the x-axis would be considered positive, and everything below the x-axis would be considered negative. So positive is going to start right here, and then it ends right here. So do your best counting over to see what that is. 1, 2, 3, 4. I think that starts at 4, and it goes to 6. Negative, again from left to right, is everything that's below the x-axis. So look at this arrow over here though. That arrow means that it's going forever to the left. It's going to keep going to the left. So it's going to start at -infinity, and it stops right here at 4. Then the last thing we're going to look at is the end behavior. So the end behavior is what the ends of our graph are doing. Now, end behavior has to have an arrow on it to have a direction that it's going. So we're going to worry about this end behavior, but this end behavior over here, it stops. It doesn't go towards anything. So we're not going to worry about end behavior here. We're only going to worry about end behavior over here. So let's look at what's happening over here. So as my x's go towards -infinity, what are my y's doing? Well, my y's are going up, so my f of x's are going towards positive infinity because they are going up. All right, same thing on this last problem here. So we're going to do all of those same things again. So increase, decrease, positive, negative, and end behavior. So this is positive slope, negative slope, negative slope. Okay. So when do I have increase? I have it starting at -6 and ending at -4. And that's the only time I have increase. I have two sets of decrease though. The decrease starts here at -4 and stops at 0. It starts again at 3 and stops never. It goes to forever down, right? Because it's going always to the right. Okay, positive is where we have above the x-axis, and negative is where we're below the x-axis. So above the x-axis, we actually have one part above the x-axis. We have two parts below. So above the x-axis, when we're looking at that, we're going to go from here, which is like 5.5, -5.5. And above the x-axis starts over here at, it stops over here at like 3 point, probably 7 or something like that. Just make your best guess. Everything else is below the x-axis, so we're going to write two intervals of below because I have two spots where it's below. I have here and then I have here. So this really starts at like -6 and goes to -5.5. And then this one starts at 4 and goes on forever to infinity. All right, the last thing we're going to look at on this is end behavior. Again, on end behavior, don't have to worry about that one because it doesn't go on forever. But we do have to worry about this one. And I'm just going to write my end behavior up here, I think, this time. So as my x's are going towards infinity, because we're heading towards the positive numbers here, my y's are going down, and down would be towards -infinity. So this is my end behavior. All right, you're going to probably have questions on this, so come see me with your questions, but good luck on your homework, you guys.